How's it going, everybody, and welcome back to our Cisco Enterprise series. In this video, we're going to pick up right where we left off in the previous video for standing up a bunch of additional BGP peerings, and we're going to look into how to control some of the routes that we've got going on. It's not going to be terribly complicated, but what we need to do is look at how do we control what we're advertising. So right now, we are doing everything in the global routing table. We haven't added anything for VRFs. We haven't done anything like that yet. So what I'm going to do here is I'm going to show you on, I'm actually going to pull up my friend Google here, and we're going to do a little bit of knowledge transfer first. Actually, I'm going to go, we're going to keep this, I'm going to switch out to incognito mode real quick. Let me flip over here. So the first thing I'm going to do, well, I kind of like that. Okay, so let's go to Google first. And what we're going to do is we're going to look at BGP bogon prefix list. So what this basically is, what is a BGP bogon prefix? A bogon is a route that should never appear in the internet routing table. A packet routed over the public internet, not including over VPNs or other tunnels, should never have an address in the bogon range. So what we're going to do is this. We're going to go to BGP help, and this is something that I definitely think all of you guys should look into, is anything RFC 1918 address space, loopback, valid IP addresses, not allocated by IANA, stuff like that. So this is basically this space right here, right? 10/A 164/10 127 1692. Anything RFC 1918, 224.003, which is going to be your multicast range. So this is essentially the syntax that we want to create on the routers, and then we can go. So this would be the service provider's configuration. So what we would do is we would have the prefix list created, and I'm going to call it. They call it Martians because it's supposed to be alien. Right? It's not supposed to be in our environment. By doing this with a prefix list inbound, so we'll deny all these subnets and then we'll permit literally everything else. We're going to go underneath our local BGP process, and then we're going to apply this syntax inbound. Now you can do prefix list filtering if you'd like. We're going to be doing a lot with route maps, and I'm going to spend a little bit of time talking about route maps in this particular section, because they need to be talked about. Because I really haven't done anything with OSPF or EIGRP when it comes to route maps or prefix lists thus far. So we'll have to dig into that. So this would be the Juniper configuration, and they have, so yeah, there's that. So we're basically going to take this syntax right here. I'm going to take this, I'm going to copy this out, because this is actually a really good example of what I want to do. This is why I pulled this up, because it's going to be something that we don't have to worry about doing on the customer side. We can do on the provider side, which is actually where this up is going to exist. So I'm going to minimize this. I'm going to go ahead and put this in the notepad, open up a new tab, and paste this in. And what I'm going to do is basically I'm going to, let me go ahead and get out of the way here. Like this, and then we're gonna do this for anything that's customer facing. So we can call it Martians. That works, gets the job done. And then and so there's a question: how come the prefix list sequence number goes 130 and then jumps to 9999? Simple answer is I can enter additional sequence numbers between 130 and 9999. And I can permit whatever I'd like. So this gives us a lot of flexibility. So if there's 6,000 other entries that we want to do, well, it wouldn't be 6,000. Let's say there's another 500, give or take, that I want to put in here, then I'd be able to do that and be more specific if I want to. Can you manipulate these and make them start off at 1, 2, 3, 4, 5, 6, 7? You can. You can give it whatever sequence number you want, really. So it just happens to be, normally prefix list goes 5, 10, 15, 20, 25, 30, but this is what we're going to go do. So I'm going to start this off on, let me go ahead and get that out of the way. Let me scoot this guy over. So on R26 is where we're going to start this. So don't worry about this. This is some sort of TCP timer. Anyway, not too worried about. So, excuse me. So I'm going to first start off with this. I'm going to copy all this in globally. So that took. And then what I need to do is do show IP BGP summary, and anything that connects to a connection provider, so a customer. So in this case here, it's going to be easy to detect 65,001. So we're going to type in router BGP 1. Then we're going to do this command right here. Let's scoot this up just a touch. And I'm going to type in neighbor of 1.26.33.33. I'll type in prefix list, prefix, address family, IPv4 unicast, neighbor of 1.26.33.33, prefix list, and then it's going to be Martians in. Now, I'm going to do a Control A to go to the beginning of the line, put the exclamation in there, so Shift 1, and then I'm going to do show IP BGP. I'm going to see all these 10 nets, all this other stuff showing up here. When I put this prefix list into play, I'm going to see all this stuff go away. That's my intention. So if I do show IP prefix list, I see Martians, right? And if I do detail, right now there's no hit counts. So I'm looking for hit count. So Nexus doesn't have this, iOS XR doesn't have this, iOS and iOS, I don't think iOS XE does either, but we're going to find out here in just a minute. So what I'm going to do is I'm going to hit the up arrow, and I'm going to pull that out. I'm going to hit the enter key, give that a couple seconds, and then it's going to take some time for it to trigger, but once it does, it's going to detect. So we see if I do show IP BGP, I'm going to start seeing some of these routes start to go away. At least they should. So I'm going to do clear IP BGP star soft. Okay, so I'm starting to see hits. So, okay. Some of this stuff is not triggering, so I might have to get more specific with it. So, let's see here. So when you run into these things, it's assuming that you're going to be matching on this. So let's see here. This stuff should start to filter out. Okay, why is this not triggering? So typically speaking, when you see this stuff coming through, this is what you have to be careful of. Is I'm looking for anything. I'm basically looking for anything in that range. The drawback to this is I don't see any hit counts. This is what I'm looking for. I see a hit count on this one. So show run section BGP. So I have that happening. So actually, let me do this. Actually, I take that back. Let me do a show IP BGP. I bet you I'm learning a bunch of stuff from, I'm learning it from other peers. Now, if we, okay, so it actually might have worked. So I'm learning stuff from I'm learning stuff from R33. Because R33 has a bunch of routes coming in. But look here. Show IP BGP. I have a bunch. Okay, so he's not learning anything from internally, which is actually kind of funny. I'm not sure why show IPBG or show IP OSPF neighbor. So show IP route. Oh, never mind. Sorry. Don't listen to me. Sometimes. Okay, so what I need to go do now is I need to continue to do the restrictions on the other routers. So what I'm going to do is I'm going to go to XR44 and do the same thing there. So let's go ahead and log into him. And this is a prefix list, so it's IP prefix, IP, the prefix, I don't want to do a prefix set, I'm going to do IP prefix list, prefix set. What are my options here? XR could be a little trickier to work with than, I wanted to do a prefix list. Prefix dash list. Yeah, it's like it's stuck on that. Prefix set. Okay, fine. I'll call this Martians and hit the enter key. And then underneath here, this one's a little trickier to work with because you got to do a bunch of commas. So I'm gonna do 0.0.0.0/8, and then you can do a LE32. And then you have to do a comma, and then do another entry. So it's going to be 10.0.0.0/8 LE32, comma, so on and so forth. So the ones I really care about are going to be the 192.168 range. So it's going to be, or I'm sorry, RFC 1918. So 172.16.0.0/12 LE32, and then 192.168.0.0/16 LE32. Now that I've done that, if I do a show config, that's what I've matched on, right? So now what I need to go do is these are not, how do I say this? These are not, these are just matches, right? So what I need to go, actually probably would make more sense to do an IPv4, there it is, no prefix set Martians. That's my fault. IPv4 prefix list Martians. And I need to go, let me go do this. Create another one like this, but I'll do v4 here, v4, just like this. And then I should be able to copy this in just like that. And then I'll be able to go to the peering. So in this case here, it's going to be 3442. Router BGP1, neighbor 1.34.42.34, address family IPv4 unicast, and then I should be able to do a prefix list. What are my options here? I might have to do a route policy. Yeah, that's what I'll have to do. Route dash policy. So show run pipe begin route dash policy. So eBGP peer, and I have that applied. Show run router BGP, and I have that applied inbound from. Did I not set that one up? 44 doesn't have one set up yet. 134. Okay. Do show IP interface brief. 134. Wait, what? Gig 3. $103. Am I in the right box? Whoops. Wrong box. 44 is where? Where's XR44? That's okay. He's still going to need it anyway. At least I have an IP. So what I'll do, 42. Let's go back to 42. I didn't realize I was on the wrong device. So make sure you're on the right box. Big T, we're going to go ahead and copy this into here. Okay, and then we're going to go to route-policy Martians, and we're going to go say if destination in prefix, actually, hold on, it's one of those prefix set names. See, it's it wants you to use the prefix. If destination dash prefix in, there is a way to map this, and I forget how you to, if it's destination, if destination in begin inline prefix, so you can basically copy and paste all that in. There's a way to do the $sign to map this, and I forget how to do it. So if we do a, that's the only thing about RPLs that I don't like. Let me think here how I would do this. Because I don't want to have to do this inline. So let me come back to this one. I might actually have to do a prefix set. So prefix set, we'll just do Martians. And underneath here we'll do, might be easier, prefix set Martians. Go ahead and pull this out real quick. And then we're going to do, so let me pull this into Notepad++. Let me do this. This is where sometimes having a text editor like this is much easier to work with. So we're going to basically grab all this. Let me grab this piece right here. And I'll grab these, press the Alt key, and then highlight what you want to delete, and then it'll delete. So I should be able to do this here as well, just like that. Oop, page up, and just delete this. And I actually want to get rid of this one because I'll have to do a pass. So then what I have to do is this. I should be able to do okay, that should be everything. Did I miss anything? No, I did not. So let's go ahead and delete that. And then we'll grab all this like so. Hopefully this will take. Let's see. Okay, exit out. And show config. So we have our prefix set. So we're going to say no. For the sake, so yeah, I could probably get away with that. So let's do route policy Martians. So we're going to say if destination in Martians, then drop. That's the command we want to do. Then drop, else pass. That's what we want to do. Else pass, and if. So if we exit out and do a show config, syntactically we want to say, well, we'll apply this inbound to both peerings, 3 and to 2. What we're going to do is we're going to say, if the route policy Martians, if the destination is in the prefix set of Martians, then we're going to go ahead and drop it. If it's anything else outside of this range, we're going to go ahead and pass. So I'll have to do a show run router BGP. And then for this 134.42 peering, we'll go underneath router BGP. And then I'll go underneath this guy right here for the in and for the out. So I want to do it inbound from the customer. We'll do route policy Martians in. And then for the same thing with this guy. We shouldn't have to do that. We should be okay with just that, because we'll do it for this peering right here on 62. Whoops. Minimize. Wait, hold on. What did I just do? Okay, go back to this. I screwed up that. So because we're trying to do it inbound, we only need to focus on this particular peering right here. So if I hit the commits, if I do a do show IPBGP, right now we're getting stuff from 62, right? And 60. So those are going to be, and once we block it from 62, we'll also stop receiving it from, right now we're not getting anything in from 34, because 34 is only, doesn't get anything. But from a customer reception perspective, the provider doesn't know who 34 is peered to. So to prevent things like this from happening from 34, let's say 34 performs a peering with 62 and then gets a full table and passes it on to us, we want to block that type of stuff. So we're going to go ahead and commit that. And if I do, so now that that's been applied, so do show run router BGP, we can see that Martians is applied inbound. So now what I'm going to go do is I'm going to go to 62. I'm going to pull up Notepad again. And we're going to do this one again. So we're going to do a show IPBGP. And the idea here is to say, right now we're getting 358.62. So we're getting a lot from 58. So we definitely want to put it on this peering. Do I not have a peering to 3362? I guess I don't. Show IPBGP summary. I do have a peering from 33362, but I'm getting a couple of routes, which is fine, no big deal. But see, I want to definitely knock this one out here because I'm getting 50 routes. I'm getting all those internal routes. I want to block all those. So I'm going to go on 62, and I want to go grab this line of config right here, copy this into here, and then we're going to do show run pipe section BGP and router BGP 3. Actually, no, wait, 6245. Underneath the address family IPv4. I'm going to type in neighbor of 3.58.62.58. I'm going to say prefix list, and it's going to be Martians inbound. So if I do show IP prefix list detail, once this takes effect, do show IPBGP, and I do clear IPBGP star soft, I'm starting to see hits, which is what I want right here. This is what I was looking for earlier. This is what I want to see. I see 192.168.16. I see 172.16 right here. So if I do, now if I go to here, I have a much more abbreviated routing table. This is what I was wanting you guys to see. I only see public addressing, which is exactly what I'm looking for. So now if I eliminate that, if I go to 42, and I show IPBGP here, I'm starting to get eliminate a lot of routes that I don't need, which is what I want to see. So now I go back to 62 and I do write that config, which is what I want to see. I can then go over to the other side of the network. Let's go ahead and minimize this guy down, and I can look at something like, because I don't have any peerings to any other sites, what I will do now is I will focus on let's see, where else do I need to go? 20, check 20, let's check 29. If he doesn't have any prefixes from there, I should be okay. That's the one I should have really focused on, but it makes sense for what we did. So if I check 29, let's see what 29's got. Show IPBGP. He doesn't have any routes either, which is what I want to see. He's good to go there. Let's see, 61. Show IPBGP. Okay, cool. So now, just because we got all these configuration, or at least all the most of the RFC 1918 space is now gone because this peering has been taken care of, we still have to deal with things like 24 and 23, which are connected to the MPLS environment that aren't currently peered yet. So we're still going to do on XR45 and 63, we still need to do peerings here, and on XR44 to 59. Now, realistically speaking, 59, if we were to go and do a show IP route, 59 has all these routes, right? So, but we're just not doing redistribution on here. So if I do a show run section OSPF, I'm not redistributing BGP into OSPF or OSPF into BGP, right? So what I'm going to do is I'm going to do that right now just so you guys can see it. Again, we're going to do a basic redistribution use case, but one of the cases that we need to take into consideration is the moment I do redistribution here, which we will be doing, I'm going to do it right now, is we're going to see stuff show up on XR44, and I just want to make sure my config is correct. So that'll be one quick way we can test it, is by doing that. So, and I actually, you know what? I can do it on R34 as well. So it's just already there. So R34, show IP route. I have BGP and I have OSPF. So since I've already got the config on XR42 complete, I might as well go ahead and do it here too. So do show run pipe section router. So underneath OSPF, I'm going to type in redistribute BGP 65001 subnets and router BGP 65001 address family IP4. We're going to redistribute OSPF 1 and hit the enter key. So then if I go to 42 and I hit the up arrow, show IP BGP, the routing information should start to propagate. So let's just double check to make sure that 13, do I have 13? I don't have 13 pulled up yet. So on 13, pull him over here. 13, if I do a show IP route, right, we're learning 34, we're learning these prefixes in, which is what we want to see, right? So I don't want to see any of these prefixes right here, right? This is what I don't want to see. But we'll talk about that in, we've already sort of discussed that, but I want to make sure that 42, I don't see a bunch of routes that I don't want. So if I show run router BGP, the Martian's prefix set that we have, so show prefix set show prefix. Oh, that's funny. Show route dash policy. Is it RPL? Show RPL. Route policy. Right. So here's what we're doing. Right. So we have all these are being matched. So just to test it, show run router BGP. If I was to go to global config and go underneath this guy here and to this neighbor and do route policy eBGP peer in and commit that, it's not going to block anything, and do show IPBGP, we're going to get all those routes again, right? So my route policy Martians in, commit that, and then do a show IPBGP again, they go away. So we know the route, we know that the prefix set and the route policy is doing its job. So we're blocking all the routes we don't want, which is what I wanted to see. So we're basically going to copy out of 42 what we out of 42 onto XR44 what we want, so we can see that config. So we're going to do a show run begin prefix set route dash policy. Can I not do? Do I have to do the route or RPL? Nope, that's not it. Let me do, is it like Nexus where you have to do this? Nope, that's not it. So I can only do one at a time. Show run prefix set. Incomplete command. Martians. Show run RPL. Okay, so this is what I wanted to see. Prefix set this guy right here and this guy right there. Okay, so I'm going to go to 44. Log in there, go to global config, copy and paste that in, and then do show run router BGP for the peering to 34459, so router BGP 4463, and then this neighbor right there, we're going to say Martians in, commit. Now, even though we're not doing the config yet, there's no BGP to OSPF redistribution here yet. I'll cover that. I said I would configure it, but since we're right, we've already just demoed it on 4042. It'll be the same config, so I'm not worried about it. We're going to do the same thing on, let me scoot over here. We're going to do the same thing on 65 and 66, just to protect, I'm sorry, I take that back, 45 and 63. So we'll go ahead and pull this back up here, and then we'll go to 26, show run section prefix list. I'm going to grab this command right here, grab all that. We're going to go to 63. We're going to copy and paste that in, and then do show run section BGP. Router BGP 4463, address family IPv4, and then neighbor of, actually never mind, I don't need to worry about that because we're not going to do BGP peerings there, so my mistake. So actually I can go ahead and say no IP prefix list Martians. So that'll take care of that. So I don't need, since I'm not going to have BGP peerings here, I don't need to worry about it. So we're good to go there. So that's essentially how that comes into play. So now, what's the next step? We've locked down the internet, but what we also have to take into consideration is what we don't want to receive from the internet. So we don't want to have all this redistribution on 33, 34, because if we pull up our routing table again and we look at router 25, do a show IP route, I have a bunch of internal internet routes here. I don't want any of this internal. So how do I fix that? And the answer to that question is I would have to do a filter inbound. From OSPF into BGP, I'd have to filter those prefixes out. So what I would do is I would permit RFC 1918 from BGP to OSPF, but I'm not going to permit anything not in that range. So the idea would be to block it inbound. So what I'm going to do is on 33 and 34, well, it's being received multiple times. So if I look at 58 as well, show IP route, I'm receiving a bunch of routes there as well. So I want to be able to, in OSPF, it's okay if I learn them on this router, that's okay. But when I redistribute them into OSPF, I don't want to learn them. So what I'm going to do is we'll test this on 33 first. Oop. So show IP BGP, perfect. Show IP route, good, looks good. Okay, so now what I had to do is I had to create a prefix list and say, type in IP prefix list, we'll say RFC 1918, oops, 1918, and we're going to say permit 10.0.0.0/8 LE32. We're going to do permit 172.16.0.0/12 LE32, and then 192.168.0.0/16 LE32. And then we're going to, that'll allow anything RFC 1918. Okay? So now what we need to do is go to do show run type section OSPF, router OSPF 1, and type in, we're not doing any redistribution at the moment, right? So because we're not redistributing, where do these routes come from? They're probably coming from 58 if I had to gander. So show IP OSPF database for, let's see, 25. So it's, I'm learning, these are external type 2, so show IP OSPF external, or database externals. They are probably coming from 50, okay, 57 is learning them on 58. 34, but I'm not doing any redistribution on 34. Oh yes, I am. Okay, so this is where I actually need to do it. So that's why I'm having the issue that I'm doing. So what I would do is, so in this particular case here, this is a classic reason why you don't redistribute BGP into OSPF without doing some sort of filtering if you're going to be receiving the full table. So we're doing the full table because that's what I'm demoing. So what I want to do is, if we look on 25, is telling me that I'm learning 221.61 from router 34. So what I can simply do is I can stop doing redistribution on 34, because that was just a demo to show you that 42 is doing its correction. So that's what I'm going to do. I'm going to go to 34, and I'm going to type in no redistribute OSPF 1, and then router OSPF 1, no redistribute BGP into OSPF. Okay, so now that should stop that. I go back to 25, and I do a show IP route. Those routes should disappear. So now they're coming from 57. Right, so we're losing a lot of those subnets. 57 is still learning them, so 57 is learning them from, where's 57? Do I not have 57 up here? I guess I don't have 57 pulled up. Let's pull up 57. Thought I had 57 pulled up. I guess not. Let's move 57 over to here, and we're going to do a show IP route. Where are these coming from? They're OSPF N2 routes. So what I have to do is on 58, this is where I actually have to do the filtering, because I am redistributing BGP. I'm redistributing BGP into OSPF or MPLS VPN. That's where that's coming from. So what I did on 34, this prefix list, I think is where I did it, right? No, I think I did it on 33. 33, yes, right here. I'm going to take this prefix list. over to 58. Copy and paste that in. And then I'm going to do a IP prefix list RFC 1918. And the syntax is going to be basically this. I'm going to put in sequence 1000 deny 0.0.0.0/0 LE32, which is deny everything else. So then what I get to go do is when I do my redistribution of BGP into OSPF, so do show run section OSPF, and I do this. When I redistribute, I should be able to do a route map, and I'm going to call this BGP to OSPF, and then I'm going to go to route-map BGP to OSPF, say match IP address and prefix list, and the prefix list is RFC 1918. So by doing that, I should no longer learn anything public here. So show IP BG, actually at 57 is probably where I would have to, and that seems like it did the trick. So delete path, let's see, global rib, show IP route. I think that might have been a winner. Because before I had, let's scroll up here, it's going to go all the way back. Yep, so I had all these OSPF N2 routes. Okay, so I'm coming from 58, and now it said selectively deleted all of these routes from 58. So that means all of my, now if I look back here in my routing table, 10, these routes are allowed, right? So my route map filtering on 58 was correct. So if I do show run pipe section OSPF, I said allow redistribution of BGP into OSPF, which is this, but I want you to match on this route map, BGP to OSPF. If I do a show route-map, I'm saying match anything that's in this prefix list, RFC 1918. Show IP prefix list, and I have, if I do detail, there should be hits. I have 10 hits on 10/8 because that's really all the routes that I'm advertising right now. And that's essentially what we want to do. We want to make sure that we are protecting our network, and this is how we want to do it. So by doing that, I've got there's other hits that came through, and if I look at the 10 and I jump over to 57 and I scroll up here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that tracks. I had 10 prefixes that got erased, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So my 10 subnets that I wanted to have, removed from the global routing table, from BGP to OSPF redistribution, were correct. So now that I've got that, my internal routing table is stable. I have a default route to the internet on 57. So everything else looks pretty good. So then if I was to attempt, say from this router, to ping, actually I had to go to, let's go pull up Secure CRT again, and let me pull up PC68 because PC68 has, do this. Let's go ahead from PC68, let's try to ping the internet server right here. Let's see if we can do that. We're going to ping quad 8. Okay, we can't ping it yet. Let's do a show IP interface brief. I have an IP address assigned through gig0/0, which is what I want. So why can't I ping it? Can I trace route to quad 8? Oh, I gotta remember this is a switch. Trace route. Okay. Ah, I know why. Oh, actually, hold on. I hit 33. 33 doesn't know how to reach it. That's the problem. So this is why we have to. This is why we troubleshoot our problems. So 33, and I do a debug or undebug all. Show IP route. I see quad 8 coming in 333 62 62. Okay, let me pull this off screen. So can I ping quad 8? I can. How come 33 can't? Show IP access list. So I have 10.1.10. I hit 33, but I can't ping outbound. Show IP NAT NVI translations. So I have the static NAT that I configured. It's a future video that you guys will see. But how come? Let me see here. What does the internet server not see? Show IP route. Internet router sees all the subnets coming through. I think I saved the config too, right? I did. So quad 8 is being propagated. I'm tracing, but I can't get there. Let me go back to 33. We're going to do a trace route to quad 8 numerically. So what is the deal? Is it because I don't have this subnet here advertised? I think that might be the case. Yes. Let's look at 62. 333, 62. Let's look at 62. Show IP route. And well, 62 is locally. Okay, maybe that's the problem. R33 to CC Control Shift 6. Show IP route. Do I see 3162? And that's the problem. I don't have a 3162 subnet in here. So what I'll do is I'll go on the internet server here, and I'll do a show run section BGP, and I'll go to global config. I advertised the local subnet, but I'm going to do router BGP 101, address family IPv4. I'm going to do redistribute connected. And then I'll do write. And then as soon as I do that, I'm going to look at 33. And then I should have a 3162 and a 3144. There it goes. Go back to 33. Trace it. Okay, but why is this still not pinging? I'm still not able to trace all the way through it. Now, what does the iNet server see? Does he see everything? 126.33. Okay, so if I do a ping, I should be able to ping that, but I can't. Let me go back to 33 and let me adjust this show IP access list. We're going to say IP access list standard NAT ACL, say no 100, or I'm say 100 deny any, and then we're going to log it. And so now if there's an entry for it, we're going to try to do we'll try to ping it again. Let me attempt to do this too. Let me go to here. I'll do a username is going to be Cisco, privilege level 15, password Cisco, line BTY 0 4, login local, and transport input telnet. Save that. So now I can do an actual telnet to quad 8. And I'll be able to look at router 33 and show IP NAT NBI translations. So it's not even attempting to get there. Control-Shift-6X. Let's look at PC69. PC69 is also set up for this. So let's pull this back up. Show IP route. Okay, so let's try to ping again. I don't see anything happening here. Let's debug IP packets. No, I don't want to do that. It's going to be too. So trace route, quad 8. Yes. I hit 33. Why am I getting blocked? But 33 can trace route to quad 8 numerically, and I get there relatively painlessly. Well, now I'm getting blocked again. I was tracing before. What is the deal? Control-Shift-6. Why is that? Show IP route. So I have quad 8. All of that is correct. Oh, wait a minute. Yeah, that's okay. Control-Shift-6 on that. So I can get to my edge. Show IP NAT NBI translations. Show IP access list. (10.1). Okay, so I'm definitely. If I try to ping it, it's not even triggering in the matches anymore. Let me go attempt to do this from like switch 17. Let's try that. Let's ping quad A here. See what happens. Go back to R33. Let me source on switch 17. Let's source from a different place. So PC7, switch 17, show IP interface brief. Well, it shouldn't matter because they're all 1017. Why am I being blocked here? I'm legit surprised. NAT should be triggering. Why is that being blocked? I should be able to reach the internet. Can I, from the internet server, can I ping 3 dot? Oh, okay. I'm just, I completely forgot. I'm thinking we're coming this way. I forgot to enable NAT on gig 0/2. That's what the problem is. So we go to R33, show run interface gig 0/2. I don't have NAT enabled on that. Interface gig 0/2, do show run interface gig 0/1, interface gig 0/ IP NAT enable. So that's what the problem is. So if I go over here to PC68 again, I can ping it. Access list show that. So I should be able to go trace route to quad 8. Yes. and I go the direction I want to go now. So I hit 333.62.62, quad 8. So if I go to here and I do a telnet Cisco and do a show IP NAT MVI translations, I have an active, oh, and there's all the UDP messages. ICMP, it's kind of funny how all of a sudden now the ICMP messages are coming through. Because the last time I tried doing that, it didn't work. Control-Shift-6X. Exit out. So now if I try to ping again and hit the pings are showing up, which is what I wanted to see out of the gate, which is kind of weird. But the ICMP 126.33.33 21.21.21, that works. So at any rate, it's doing what I want it to do now. So now that I've got that squared away, and I forgot the NAT piece to that, we are good to go. So now what I can start doing is walking you guys through how would you adjust things. Like, so for example, I'm not going to do it now. I'll do it in a follow-up video. Because I have two different peerings, I could go here and say wait. I could set wait on this neighbor and make sure I would go this direction instead. And if I had local preference was telling me to go, once wait points me this way and tells me to go to 42, I could tell it to go to 60 instead. And then it would go this path instead of this path. So it's going to give me some flexibility in terms of what we're doing. So that's the whole point of what I'm trying to demo for you guys. So with that being said, if you guys have any questions, comments, concerns, anything like that, drop a comment in the comment section below. If you haven't already done so, please like, share, and subscribe. And I'll catch all of you guys in the next video.